Namaskara, namaskara, namaskara. Welcome to the first amazing academic session for your second PU 2025 Karnataka State Board examination. Obviously, we have done a lot of sessions, be it mock test, be it theory, be it lot of questions, or even be it strategies. We have done it all, but it's something special when the exam comes near and we have to do the complete syllabus in a power packed manner in a short duration of uh, you know time. So let's start, my dear warriors. I'm pretty sure you would have checked the strategy and also the day wise plan. In case you have not checked it out, please check it out on the channel. So today is basically your 70 out of 70 target, 100 plus MCQs, filling the blanks, whatever those one markers. That's what we are going to do today, my dear students. And those of you who do not know about the plan, check it out. It's there on the community post. Of course, it's been put up over here. You can see the entire day wise schedule. Some of you are like, sir, 7th March exam ide. When are you going to take the session? Well, it's going to be at 5 o'clock in the morning. Shreyas sir is going to come awake. Yeah, wake up for all of you. And do not forget, Vidya also offer ends today, tonight. So if you are interested for KCT and Comed K preparation, please join today because the prize benefit will come. You can start preparing later on, that is secondary, but the main thing is you should start off today. Okay, so you should join off today so that you can at least get that prize benefit. In this particular video, I have put up all the links of all the test series, all the courses, everything over here, which are as per the Vidya Utsav offer. So tonight is the last time that you will be able to avail it. Later on, you can start preparing. That is okay. All right. So let's begin with the class, my dear warriors. And yes, let's begin with the amazing questions, MCQs. Hi, Revati. Hi, Samuel. Nice to see all of you. And I'm so glad you are all here. Smash that like button. And if you want 60 plus, then please like this particular video. Done, sir, already. Wow, very good. And some of you did it late. It's okay. Better late than never. All right. So let's begin. And here it comes, the first question on your screen. Definitely. Okay. Those of you who do not know me, my name is Captain Shreyas. I've been teaching physics for more than 13 years, sending kids into lots of good colleges. Well, I have done my BTech from NIT Nagpur and I did my research from IIT Bombay. So that's about me. You can introduce yourself by putting up your city where you're from in the chat box. Thank you for liking and do not forget to subscribe to Vedantu Karnataka. So let's start. Here comes the first question. When a glass rod is rubbed with silk cloth, where do you think the electrons go? Who acquires that negative or positive charge? That's the question. Everybody answer in the chat box. I am waiting. Yep. Even if you're watching it as a recorded class later on, try to think, try to recollect what you have studied. Open up your NCRT, open up your textbooks, open up your notes. It will be there. Is it A, B, C, and D? I want that participation. I want that participation, everyone. Come on. Yes. Is it A, B, C, or D? Is it silk cloth will lose electrons or glass will lose electrons or glass will become negative or silk will acquire positive? I think glass will lose electrons because glass becomes positive, silk becomes negatively charged. So this option D is wrong. Silk should become negative, glass should become positive, glass loses the electrons. So that is how it is. Yes, glass loses the electrons, glass becomes positive. Yep. And silk becomes negative. Yeah, silky. Okay, so the silkiness, that's how you should remember. The silkiness will attract those electrons. Electrons will come towards that silk, dairy milk silk. Remember some random, some chumma, some example, okay? Some random example. Oh, silk, dairy milk silk. Electrons are slipping into that dairy milk silk and entering them. That's how you can remember it. Next question. Which of the following charges is not possible? This is based on the concept of quantization of the charges. Quantization. Okay. Yes. Come on. Think about it. Okay, Game Shock. Awesome. Dairy Milk Silk, isn't it him? Very good, Dev, Samuel, Reti, Alma, Sushank, Naveen. Awesome. Namaste, Preeti. Good evening, everyone. Come on, join in. Join in. Remember, the basic charge is 1.6 10 to the power negative 19 coulomb. So, this is exactly that multiple one time. This is two times. This, I don't think so. This is four times. 4 into E. This is sorry, this is two times. This is one single electron. So this is not a multiple of 1.6. 16 2s are 32. 16 3s are 48. 16 4s are 64. 56 is not coming anywhere in between. I think it is C. How many of you said C? Very good. Hi, Girish. Very good, Arif, all-rounder. Karun, Preeti, awesome. Samuel, Akash, Yashas, great. Sanjeev, great, great, awesome. Moving to the next one. The direction of electric field at a point on the equatorial line of a dipole is. So, come on, think. There is a dipole, electric field on the equator. If this is the dipole, this is the axis. This is negative, positive. This is the axis. This is the perpendicular is the equator. So if you go perpendicular, that is equator, where will that electric field be? Okay, Tarun, welcome. Welcome. Come on. Yes, where is it? If dipole moment is this side, the electric field will go like this and come like that. So when it is going through the equator, isn't it going opposite to the dipole? Dipole moment is there. Electric field comes like this, opposite. Yes, it is opposite to the dipole. Option B. Option B, Haley. Option A, option C, wrong ಇದೆ. Yes, option A, option C, wrong ಇದೆ. So be very careful. Okay, if I change the question, instead of equator, I make it axis, then what will the answer be? On the axis, wherever the dipole is, exactly same direction, the electric field will be pointed. So on the axis, same direction. On the equator, opposite direction. Okay, fine. Sorry, let's move on. Name the physical quantity which has the dimensional formula length raised to 1, time raised to 1, ampere raised to 1. What is that physical quantity? Very tricky. Okay. Yes, Diksha Karnataka basically is, we can say our sister company, or basically Vedantu, in Karnataka is taken care by Diksha. Yes, not Diksha madam, but Diksha Karnataka. Diksha was is a very popular offline plus online institute. So, Vedantu is closely associated. They are a part of Vedantu now. It's not like it's just a temporary tie-up or anything. No, we are closely associated. They are a part of Vedantu now. So wherever you see Diksha, that's basically Vedantu. You will see Diksha Vedantu written everywhere. Okay? All right. Linear charge, capacitance, dipole moment or charge. See, charge will be ampere into time. Ampere, current into time. So this is wrong, D. Dipole moment is charge into length. Charge into length. Oh, option C. Yes, capacitance. No, it is very big. Something and all is there in it. Lot of things are there. Linear charge density, that is charge per unit length. So length will be below. Dipole moment seems to be the correct answer. See guys, why? Do you understand why dipole moment is the correct answer for this particular thing? Understand it. Dipole moment is charge into length, and charge is current into time into length. So current is measured in ampere dimensionally. This is time. This is obviously L. So ATL. So that is basically C option. Everybody, this answer is marked wrong. Ignore this. The correct answer is option C. Option C. Is that okay, everybody? The correct answer is option C. Ignore what has been marked. Very good. Yep. Okay. Okay. Moving on to the next question. Ignore the answer mark. This is not correct. Okay. All right. When a free electric dipole is placed in a non-uniform field, what do you think will the dipole experience? There is a dipole, meaning two charges. It is placed in non-uniform. Read the words carefully. Non-uniform field. Both force and torque. Force but no torque. Torque but no force. Very confusing. No force, no torque. What do you think is the correct answer? Okay. Sir, in our campus, they are giving Tattva models. Yes, of course. So basically, if some institute has tied up with us and we are right now, associated, obviously we will be also giving our material to our sister channel, to our sister, institute. So obviously, in Karnataka, we definitely give our JEE NEET Tattva modules to our Diksha students. Yeah. Okay. Both force and torque. Very good. Option A helide. Option A. Yes, it is not B. Some of you got it wrong. Be careful. See, why is it option? Why is it option A? I'll tell you, very simple, guys. See, if there is a dipole, this is positive, negative charge. Okay. Example. And there is non-uniform electric field. That means the electric field might be diverging or converging. So on the negative charge, the force will be, let's say, like this. On the positive charge, the force will be, let's say, like this. Okay. So what is happening? The forces will not cancel each other. The forces will not even cancel each other. And the forces might not be even in the same direction. So there will be a torque. There will be also unequal forces because the field is not uniform. So force will not be the same. They will not cancel. So force will be there. Torque will be there because whenever you put a dipole inside a field, torque will be P cross E, P cross electric field. So that is why the torque will be there. Okay. What is the unit of electric flux? Come on, everybody should get this. Bega bega heri. What is the correct answer, my dear warriors? What is the SI unit of electric flux? What is the SI unit of? If it is uniform field, then only torque will be there. So who asked it? AIM. See, only torque will be there if it is uniform electric field. P cross E torque will be there, but force will never ever be there. They will get cancelled out. Okay. Srinivas, it's all up to you. How quickly you answer the options. Yes. What do you think is the correct answer for this? SI unit of electric flux. SI unit of electric flux, my dear warriors. Electric flux is nothing but field into area. And field is nothing but Newton per coulomb. Area is nothing but meter square. Newton meter square per coulomb. Do you see this? This particular thing is Newton per coulomb into meter square. Which is this option? Option number C, Heli. Option D wrong ide. Option A is also wrong. Option B is also wrong. Be very, very careful. Option C. Everybody with me? Understood? Yes. Very good. I think they have marked the wrong answer. See, Weber will be the correct answer. You know when? When it is magnetic flux. If the question was for magnetic flux, then it is Weber. Magnetic flux, Weber. Electric flux, electric field into area. So be very careful. Clear? Okay. Awesome. 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 Okay. ಸೊ ಆಕಾಶ್ ನನಗೆ ಸ್ವಲ್ಪ ಸ್ವಲ್ಪ ಕನ್ನಡ ಬರುತ್ತೆ, ಅಷ್ಟ ಚೆನ್ನಾಗಿ ಮಾತಾಡಿಗೆ ನನಗೆ ಬರಲ್ಲ. But most of our kids prefer to learn in English, and most of our students are also in English medium. And I know we love our language too. Even I am very much associated with Karnataka, and not just because I'm staying here, but even from my relations and from my relative side too. So I'm trying to learn. Maybe I will get better if you show me a lot of love and support. Shreya sir is definitely every day. Even if I speak wrong Kannada, I will try to learn for you. I'm trying to, make sure my Kannada improves along with all of you. So I'm making that effort for all of you. Yeah? Okay. Okay. Or else what will happen if I speak very wrong, then probably will make a meme out of me. And then that meme will circulate everywhere. All right, cool. So you should support this channel, guys. You should support this particular channel which is made for you. This is exactly for you. We are putting in our 100%, and trust me, not many teachers are putting in that effort. And specifically, I'm telling you, JE teachers. Specifically, I'm telling you, JE teachers. Very rare to find somebody doing something for Karnataka. I am passed out from NIT, IIT, Diksha ma'am from such amazing colleges. She has done MSc, now she is doing PhD. And then you have also Namrata ma'am who has done her, postgraduate from IIT. So you have IITians, NITians who are teaching you over here, specifically for JE if I talk about, or engineering field if I talk about. So you should be very proud of this channel and you should make this very, very popular, isn't it? Okay. SI unit of, again this. I think some question went wrong here and there. I'm so sorry, guys. Okay. Electric field intensity at a distance r from the center of uniformly charged sphere outside the sphere is E, which is correct. Which is correct. They have asked, not incorrect, which is correct. Okay. Sir, full famous. Thank you. Okay. All right, all right, all right, all right. Great, great. Oh, listening to my Kannada aim is like, sir, it's okay, sir. Please talk in English. All right, cool. Yeah, great. So, what do you think? What do you think is the correct answer for this? Everybody. Okay. Some of you are saying C. Some of you are saying C. Is that right? Is that right? Some of you are saying D. One person said D. Okay. Sarvajit said D. Everybody is saying C. So, who is correct? I think C is correct. The electric field is proportional to Q and inversely proportional to R square when you are outside. Read the question carefully. You are basically outside. So electric field outside is given by the formula K into Q divided by R square. Electric field inside a charged sphere is zero if it is a shell. If it is a shell. But if it is uniformly charged sphere, if it is uniformly charged sphere, then the electric field outside is the same kq by r square, but electric field inside has a special look kq small r divided by r cube. Kq small r divided by r cube, it is proportional to small r when it is inside. So for uniformly charged sphere, this is the formula, whereas this particular formula is for a uniformly charged shell. For a shell, this is a solid sphere, this is the formula. For a shell, this is the formula. If you know the formulas properly, you can definitely get the answer. All right, moving to the next question. There are charges arranged in the corner of a square. The direction of the field at the center of the square, which direction do you think it will be along? Come on. All right. I have already made Kanchana a video on how to prepare for the physics exam. Just check out that 70 out of 70 physics strategy, sure shot strategy. It's already there. Yeah. All right. Great. Can we expect MCQs like this? Definitely. Why not? Why not? Come on, my dear students. What is the answer? A, B, C, or D? Yep. See, my dear students, out here, this particular charge Q will give an electric field in this direction. This will give 3 times the electric field. This will give 1 time because of Q. This is 3 times. So this will give 3 times the field in this direction. This 2Q will give an electric field in this direction 2 times. This 4Q will give it 4 times over here. Now you have to find the resultant. See, this 1 and 3 will cancel. This 1 is opposite to 3. So you will get an effective field of 2 in this direction. This 2 and this 4 will cancel and you will get an effective field of 2 units in this direction. 4 and 2 cancels, becomes 2. Now this 2 and this 2 together will give an resultant, in this direction. So what is that resultant going to be? This is the net resultant. Which direction is it? DC, BC, AB or AD? Yes. Which direction is it, my dear students? Come on, answer the question. Along DC, along BC, along AB, along AD? No, this is along basically line CD. Can you see that? This is along line CD. Definitely, it is along line CD or DC. So it is vertical. Correct. Option A. Option A. Awesome. Awesome. Great. Sir, third chapter के numerical problems ಮಾಡಿ it's time ಸಿಕ್ಕಗೆ. Okay, definitely Girish. I read lot of your comments, sir. Numericals problem session ಬೇಕು. Don't worry. I have heard that. I will change my plan a little bit and I will try to adjust a numerical session specifically for current electricity and high voltage chapters. Okay. I'll modify the plan because many of you wanted that. Don't worry. I have heard you. Great. Which of the following shows electric field inside a dipole? Inside a dipole, basically around it, how does the electric field lines look like? Come on, my dear students. Do you see this? Some charges are here, some charges are here. Again, see how they are going. This is one charge. How can one charge be a dipole? Wrong. These are two charges, but they are repelling. Can you see the field lines are going away? So that means the charges are not opposite, they are similar. So this also can't be a dipole. Got it? So option C and option D got eliminated. Dipole means opposite charges should be there. So the field should start and end. Start and end. Oh, so then option A and B both seem to be correct. No, there is a small difference between A and B option. See, dipole means same magnitude of the charge. Here, if you notice, whatever field lines are coming here, more number of lines are going out. So the charge here is more, charge here is less. Whereas here, whatever field goes out comes back over here. That means the charges should be equal in magnitude and also opposite. It starts means positive, it ends means negative. Hence B for Basvasaurus. Yes, B for Basvasaurus. Is that clear? Everybody understood? Clear? Yeah. Oh, increase the brightness. Is it? Let me see if I can increase the brightness over here little bit. I have increased. See if it is okay. Little bit better maybe. Now I might look very bright. Anyways, name the quantity whose SI unit is joule per coulomb. Very interesting. See, if you know the physical quantities, easily you can answer this. Yeah. Srinivas, I already heard that and I have already planned for it. Don't worry. I will do the numericals for current and high weightage numerical chapters. Okay. Don't worry. Name the quantity. SI unit is joule. Joule is work per coulomb. Work per coulomb. Work per coulomb. Work per charge. Work per unit charge. What is it? Electric potential. The work done to bring a charge from infinity to a point per unit test charge. Work is in joule. Charge is in coulomb. I think it is C option. Yes, correcto. Awesome. Sneha, Pawan, Amit, Sanjeev, Siddhi. Very good, very good, Priyanka. Very good, Niranjan. Awesomeness, awesomeness. Moving on to the next question. The dimension of electric polarization. Come on, my dear students. Polarization, electric polarization. Come on, come on, come on, come on. Know it, you know it. Do not know it, gone. Know it, or you do not know it, gone. Come on. Yes. Come on, my dear students. Everybody, come on, think about it. Everybody. Yes. Come on. Okay. Some of you are saying, okay. C option, C option, C option, C option, A option. Hmm. Guys, it is basically coulomb per meter square. Coulomb per meter square, guys. So, understand electric polarization, the unit is basically coulomb, coulomb per area, which is meter square. Coulomb is basically ampere into time, and this is meter square. So ampere is there, then your time is there, and then meter square. That means length raised to -2 is there. So that is the answer for it. Option number A. Got it? Okay. Be careful. If you know it, or else you will make a mistake. Capacity of a parallel plate capacitor. How do you increase it? How do you increase it? Okay. Sampath, adding a pole option will be very time consuming. I have tried it. It wastes a lot more time than I need to make one person say continuously change it. It is very tedious. So it's okay. You answer in the chat box. Capacity of a parallel plate. What is the formula? Epsilon naught A by D. Either you increase the area, or you add a dielectric, or you reduce the distance between the plates, isn't it? So thickness of the plates has nothing to do with it. Increasing the area should be the answer, but decreasing is given. Decreasing the distance between the plates, that seems correct. So D, is that right? D for Diksha. Oh, very nice. See, some of you went wrong, said A. Increasing the distance. No, my dear warriors. No. See, the formula is, what is the formula? Epsilon not A by D. That is the capacitance. If I want to increase capacitance, area should increase or distance should decrease between the plates. Denominator decreases, the ratio will increase. Got it? Next, which of these following graphs shows the electric field with distance from the center of a uniformly charged non-conducting sphere? Come on, just now I told you the formula. Now they have asked a question on the graph. Everybody should be able to do this. Uniformly charged sphere andre, guys, the formula goes like that. Electric field inside is KQR divided by R cube. It is proportional to R. Electric field outside is KQ divided by R square, meaning inversely proportional to R square. So directly proportional to R andre straight line. Inversely proportional to R square andre, it is curved line like this. So option C should be the correct answer. Some of you said B, that is wrong. You know when is B the correct? No, B is the correct answer for the potential for a shell. So don't get it wrong. If instead of non-conducting sphere, it was a conducting sphere, then what the answer would be? Come on, guys. If the question said conducting sphere, then what will be the answer? You know what? Electric field inside will be zero. So only outside it will be there. So the correct answer would have been D option. Then it would be D option if it was mentioned conducting. If it was mentioned conducting, this one small word has changed the answer from D to C. Okay, so when it is conducting, all the charges go outside. It behaves like a shell, and inside the shell the field is always zero. So it will be zero till you reach the outer surface, and then the normal formula. Only when the charges are distributed, which can only happen in an insulator, which is basically non-conductor, then there is a field which is proportional to small r, which is the distance from the center. Got it? Okay. Next question. Next question. What's the equivalent capacitance of the combination? Wow. This looks like some cockroaches ran over when their legs were dipped in some white ink, right? So many alphabets out here. But if you think smartly, you will get the answer, my dear students. What is the correct answer? Come on. Idu lengthy ide. No, no. It is not so much lengthy. It is very simple. See, these two capacitors are in series. Series means what? The effective capacitance will be C1, C2 by C1 plus C2. Now that is in parallel combination, with C3. So the effective capacitance will be just added C1, C2 by C1 plus C2 plus C3. Now you have to basically do LCM. So it will be C1, C2 plus C3 multiplied by C1 plus C2, whole thing divided by C1 plus C2. That is what it will be. So what will this be, guys? You have C1, C2, C1, C3, C1, C3 plus C3, C2 plus C3, C2. All combinations 1, 2, 1, 3, 3, 2 divided by C1 plus C2. That is what the answer is. Which one is correct? A, B, C or D? Come on. A, B, C or D? I think I can see D option is correct. This definitely is wrong. This is also wrong. Very confusing options, but obviously you can make out now D option is the correct answer. 1, 2, 2, 3, 3, 1 upon 1 plus 2. Perfect. Got it? It is not lengthy. You just have to be very quick in solving this. 1-2 minutes maximum. Next, electric field inside a conductor is zero. Okay. All the charges reside only on the surface of the conductor. What do you think? Both are correct? One is wrong? Are they explaining each other? Assertion, reason type of question. Assertion, reason. Come on. Assertion, reason, my dear students. My dear students, assertion, reason, come on. Electric field inside a conductor is zero. That's the property of a conductor. Why? All the charges go outside. So they generate fields which end up cancelling each other inside the conductor. So the net electric field is zero. Potential is same everywhere. All the charges reside only on the surface. Yes, because the charges go on the surface, there is no charge inside. Gauss law says when there is no charge, the net flux should be zero. Net field will also end up being zero. So that's the reason for it. So it is correct and it is also explaining it. Okay, makes sense. It is not B, it is definitely option A. Yes. Is that clear? Everybody with me? No, many of you said C and D. Yo. What are you guys saying? No, it is not C and D. It is A. Whenever you take a conductor, inside the field is not there because the charges repel, they go outside. And once they are on the outer surface of the conductor, their field contribution will end up being zero once you add them up. Okay, the net field will be zero. You can apply Gauss law. Gauss law says net flux is zero because no charge is inside, and once flux is zero, field will be zero. So because charges are not there inside, that's why no flux, that's why no field. So it is also explaining that statement one. Correct it is. Yeah. Electric dipole inside a field. The dipole makes theta. What theta? Energy is maximum. Come on, everybody should spam the answer. Everybody. Namaskara, Kiran. Yeah, everybody should answer. Everybody should answer this particular question. This kind of question can come. It can be asked for minimum or even maximum. See, my dear students, when the dipole and the field are in the same direction, theta is 0, the energy is negative PE cos 0. Cos 0 is basically 1. Cos 0 is 1, so it is minus PE. This is basically minimum. Whereas when the dipole is perpendicular to the field, then the energy is PE cos 90, which is basically 0. That is not minimum. This is minimum because negative numbers are even lesser. But when the dipole is opposite to the electric field, then theta is 180 degree. So energy is minus PE cos 180. Cos 180 is minus 1. So minus minus becomes plus. So this positive value makes it maximum. So when they are opposite, that means 180 degrees. D option. Yes, D for Diksha. Perfect. Awesome, guys. Excellent. Very good. Awesomeness. Awesomeness. Moving on to the next one. Here it comes. The graphs show the variation of two quantities with distance r from a uniformly charged shell. Shell. Okay, inside there is no masala. Everything is outside. Okay, it's empty. It's a hollow sphere. Which graph is correct? Which graph explanation is correct? That has what has been asked. Come on, think about it. So, graph 1 looks like a potential graph. Graph 2 looks like a field graph because inside the field will be 0 and outside the field will be 1 by r square proportional. Potential will be constant and then it will drop down. So graph 1 is field versus r and second is oh no, wrong. Second is not potential. First is potential, second is field. First is potential, second is field. Option B should be correct. Yep, B for Baswa sir. B for Baswasaurus sir. Perfect. Awesome guys, awesome. Okay. Nayana, you are saying, Kushal, I have a boyfriend, I can't love you. I thought the actual answer should be, sorry boss, second PU exam is there, KCT is there, Comet K is there. That's why I can't love you. Ayo, this reason was next level. Salute. Okay. So guys, no time for love, no time for anything till KCT Comet K. After that, you do whatever you want. You dance, you go to Indira Nagar, you party, no issues. Okay, fine. Uh, when a magnetic compass needle is carried nearby to a straight wire carrying current, then straight wire causes deflection. The alignment is tangential to the imaginary circle with the center and the plane perpendicular to the wire. Both are correct, both are wrong. One is correct, one is wrong. Come on, come on, come on, come on, come on. Come on, think, guys. Which one is the correct answer? It's very simple. This is based on the Orsted's experiment. Orsted took a wire carrying current and he saw a magnetic needle got deflected when placed near that wire. So he then understood magnetic field is created around a current carrying conductor. So first one is definitely correct. Wire carrying current will cause a deflection. Second, that wire carrying current, if you draw imaginary concentric circles around it, that is the magnetic field. If you take the needle, you will see the needle will go along the circle's tangential path. That needle points in the direction of the field. So wherever you take, it will go in that circular path. The pointing direction which points will always be in that imaginary circle. So then you understood, oh, there are magnetic fields around it in the form of concentric circles. So both are correct. B for Baswasaurus. Awesome. 100% B says Nayana. Very good, Tejaswini. Awesome. Sampath, Sudesh, Ruzian. Very good, Srinivas. ಎಕ್ಸಲೆಂಟೇ ಸಕ್ಕತ್ಗ ಆನ್ಸರ್ ಮಾಡ್ತೀವಿ ನೀವು. ವೆರಿ ಗುಡ್ ಗೈಸ್, ಆಸಮ್, kudos. Keep on answering. If a current I is flowing in a wire parallel to the x-axis and the magnetic field is there along the y-axis, then which direction do you think the force will be? Think logically. Draw, imagine. If it is not possible, if you are not able to imagine, then draw. Current is flowing in the x-axis. This is how the current is flowing. Magnetic field is along the y-axis. Where is the force? Force is I length cross B. That is the formula. Length is along the I cap direction or along the x-axis. Magnetic field is along y-axis. Do L cross B. Use your right hand, point the four fingers in the direction of current first, and then cross it with the field. Your thumb will come like this towards you. Yes, the thumb is coming towards you. Yes, don't suck the thumb, guys. The thumb is pointing outwards. Yes, in the Z direction. In the Z direction. How many of you said Z? Oh, yo, what is this? A option. What is this? A option. No, 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 no. How will it be in X? It will be in Z. One is in X, one is in Y. Force will be in Z. ILB. In fact, ILB, remember that Fleming's rule also. All three are perpendicular. Current in X, field in Y, magnetic force in Z. Yes, Fleming's rule, cross product, whatever. Yeah. Okay, understood how to do it? Use the right hand cross rule. Okay. In the exam, I've seen some students, sir, I use cross product, sir, but I was so tense, I was writing like this, and in the exam, I did cross product with my left hand. So be careful. That is a very good silly mistake which many students do. Yeah, very common silly mistake, because most of you will be right-handed people. So you get carried away and you are in a hurry and use left hand instead of using the right hand. Okay. Radius of the circle by charged particle moving perpendicular to the uniform magnetic field depends on mass and speed. Speed, neither mass nor speed. Know the formula, get the answer. Know the formula? Yes. Rajat, no time for poll. Yeah, no time. Directly answer. It is very easy. Ayo. Sanjeev, no issue is here. Concentrate. KCT, Comet K, PO is here. I am here. Okay. If your attention is somewhere else, gone. Okay. Then Aishu will be in top college. You will be in one Laddu college. Now, both mass and speed. Very good. Because the formula for the radius. What is the formula for the radius? Yes, the formula for the radius is mv by qb. Mass also, charge also. Both are there. Got it? Yes. You should know that formula. If you know the formula, it becomes easy, or else it becomes very difficult. Next, galvanometer, the deflection is related to the current by which formula? Very easy formula. If you know the formula, you will get it. If you don't know the formula, gone. Come on. See, I'll tell you. There is a very simple way to remember the formula. Sir, what is this, sir? Everything is looking same. N, A, B, K, I. Sir, I'm getting confused. In fact, if I knew the formula also, looking at the options, I'll get confused. No issues. The formula looks like this. Theta, you put one thing in current. Why? Because theta is always proportional to the current. This is deflection. The deflection is always proportional to the current. That's fine. So that is there. What is there over here? Everybody knows football. Yeah, yes, sir. And organizers like FIFA. Similarly, cricket, IPL. Tell me, what about basketball? What comes to your mind? Football, FIFA, cricket, IPL. For basketball, what comes to your mind? Come on, Bega Heri in the chat box. What comes to your mind? Basket, sir. What is basketball, sir? If you ask such questions, then gone. Huh. NBA comes to your mind? Yes, sir. NBA comes. Oh, so put NBA. Basketball means NBA. Basketball, do you play with your hand or with your foot? What do you play? How do you play basketball? With your hands? With your head? With your back? With your chest? With your feet? What do you play? How do you play? Hey, somebody saying RCB. Ayo, first RCB, let them play cricket properly, then let them come to basketball. Uh, yeah. So they play it with the hand, right? So you should never kick a basketball. Foul you will get. Yes, you should never kick. Kick for K. K for kick. So put K below. Got it? And where do you kick? Kick is always below. Your feet are below. So denominator, not numerator. Denominator. Kick. Your feet are below. You should never kick a basketball. NBA. Got it? Very easy. Understood now? NBA by K into I. Isn't it easy now? Ah, very good. Yes. So you should never kick a basketball or else you'll get foul. Yes. Moving on to the next question. A charged particle moves in gravity-free space, no gravity, without changing the speed, which is not possible. Which is not possible. I hope you loved the trick I gave you. Shreyas sir just gave you a very nice trick. Yeah, smash the like button. What are you guys doing? Subscribe also. I have to keep on reminding you. Subscribe, like, subscribe, like. After the video ends, comment. What I'm asking? Am I asking you 100 rupees? No, right? I'm asking you free things. What? Like, subscribe, comment. That's all. Very freely available. Okay. B option, ah. Oh my God. Yes. Very good. See, field is not there. Obviously, nothing it will do. Chumma, however it was going, one waste fellow types, it will keep on going. Okay. Correct. This is there, magnetic field, but electric field is not there. Then also, what if the velocity is in the direction of the field? So velocity and magnetic field are in the same direction, no force. So then also it will keep on doing whatever it was doing. This is also possible. You know when electric field, magnetic field and velocity all three are perpendicular. This is the concept of velocity selector where the speed is electric field by magnetic field. Then there is no net force and the charged particle keeps on doing whatever it was doing before. So even D is possible. This is never possible because the moment electric field is there, 100% there is a force and that force will end up changing the speed and the direction. But magnetic field is not there to counterbalance it. So in the D option, the difference is magnetic field can counterbalance the effect of electric field and that's how the net force will be zero. That's why the velocity can remain constant in D option. Other options are simple because field was only not there. Okay, very good. Understood, clear? Everybody clear about this? Let's go then, let's go. Charge, mass, circular motion, field, radius are magnetic moment. Magnetic moment is how much? Remember, magnetic moment. Come on. Magnetic moment is nothing but given by magnetic moment by angular momentum is charged by 2 times of mass. This is called gyromagnetic ratio. Gyromagnetic ratio. So M is L into Q divided by 2M. What is L? Angular momentum, which is M V R, angular momentum, charge by 2m. M cancel. That's it. So it will be QVR by 2. QVR by 2. QVR by 2. Okay, but they have asked the answer in terms of radius. No issues. What is radius? What is the formula for radius? Radius is mv by qb. So just substitute that particular formula for radius over here. So it will be qv by 2. Instead of radius, put mv by qb. QQ gets cancelled. QQ gets cancelled. We will get mv square by 2 times of b. mv square by we have to give the answer in terms of radius. I'm so sorry. And speed should not be there. I'm so sorry, guys. I just made a small mistake. We had to replace velocity with the radius. So from here, velocity will be RQB divided by M. So from here, velocity will be r into q into b divided by m. So use this velocity over here. Use this velocity over here. So put r q b divided by m. Rest of the things as it is, which is q and then r and divided by 2, of course. That's it. So it will become q square b r square by 2m, which is exactly this answer. Okay, which is exactly option C. Is that okay, everyone? Yes, awesome, great. So this is HOTS. What is the meaning of HOTS? Higher order thinking skills. Yes, so this is a good question. Yes. Next one. A current carrying wire is placed parallel to the magnetic field. The force on it due to the field is zero. Okay. The net charge on current wire is zero. What do you think? Are the statements correct? Are they explaining each other somehow? Yes, Sampath, it is confusing, but you try it 2 to 3 times, you will get it. Practice it by your hand. Don't just say, okay, I understood. Okay, just practice it 2 to 3 times, the formulas. The gyromagnetic ratio, the radius formula, all these things are very famous formulas. Now, if you take a current carrying wire, and if the magnetic field is in this direction, then the force, which is ILB sine theta, sine 0 will be 0. So the force will be 0. So the force will be 0. And why is it 0? Because the theta is 0, because current is in the same direction as the field. So that would have been the correct explanation. The Lorentz force formula, or the force on a current carrying wire formula, or Fleming's rule. But here it says the net charge on a wire is 0, current carrying. Yeah, it is correct, because whenever you take a wire, obviously it is made of nucleus and electrons. So that electrons are the ones which charge, they carry the charge, the nucleus stays there. So the net charge is always going to be 0. So this is correct, this is also correct. But how is this explaining this? Obviously it is not explaining it. So just they are chumma correct, but they are not the correct explanation. So B option is the correct one. How many of you said B? How many of you said B? Very good. Awesome. The 2, 3, 5 markers, like I have said, my dear, I have already placed the schedule. I don't know whether you have seen that schedule. Okay, just go to Vedantu Karnataka channel, and I think the upcoming session. See, these are the HOTS and 5 marks which are there tomorrow. Sorry, today. Then you also have the next session where you will have 2 and 3 marker questions over here. Then this is passing package. Then you also have fixed questions, and then there is one more session also. I'll also plan the numerical session for all of you. Don't worry. Okay, clear? Let's go. Next question. Ammeter, millimeter are converted from galvanometer. Which one has small resistance? Everybody should spam this. Very simple question, guys. Very simple. Okay. Sir, where can I get one shot of all the chapters? Ryzen, I'll tell you, there is a channel called Vedantu J English. That's where you can get it. I'll just show it to you after this. Just answer this question first. Yeah, ammeter is always connected in series with the circuit, and that should have a small resistance. Voltmeter is always connected in parallel. It should not take in much current. So when it is connected in parallel, the resistance should be very high. So voltmeter has very high resistance, ammeter has very small resistance. So ammeter is the correct answer because it has very small resistance. Option A. Very good, excellent. See this channel, Vedantu J English. Okay, you can just go over here. Now you don't get scared, sir, J level. No, nothing. Just go to the videos part. Just go to the videos part. Just go down a little bit. Do you see NCERT chapters are there? Yeah, just go through these. Yeah, just go through this. Electrostatics, capacitance, charges, same textbook, right? For state board. So just go through this. These are big classes, proper one shots, 3.5 hours, 10 hours, 8 hours, 5 hours, 6 hours, like that. So big sessions, proper one shots are there. Clear? Okay, yes, sir. Let's move to the next one. Consider the following. Magnetic field do not intersect. If magnetic field lines intersect, the magnetic field will not be unique at the point of intersection. What do you think? This is very straightforward. If you get it, you get it, or you don't get it. Okay. Come on. Everyone. All right. J level one shots are also there on that same channel. You can go to the ROAR series on that same channel, right? Vedantu J English. You will get something called as the ROAR, ROAR, ROAR series. All chapters one shots, you will be able to find it over there. You can even check my older sessions like Legend, Nurture, all those things, Pathfinder. Those are also there. If you want it for NEET, then go to the Vedantu NEET English. Okay, Vedantu NEET English. That's where you will find the RNA series or Super 6 series. Yes, very good. Statement 1, statement 2, both are correct, and that is the correct explanation. Magnetic field lines cannot intersect, and the reason is wherever they intersect, if that happened by chance, then field is here and here. How can it be both places? Not possible. Hence, they cannot intersect. That is the reasoning also. Very good. When you take a freely suspended magnet, where do you think that magnet comes to rest? How do you think the magnet comes to rest? Okay, come on. Option A, B, C, or D. Yes, very good. North and south, right? Every magnet, when suspended, it goes in the north-south direction. Option A. Yes, everybody has shouted the answer and given it. Next one. Magnetic susceptibility is 100. Then the relative permeability will be relative permeability. What's the formula for it? If you know it, you know it. Relative permeability is 1 plus magnetic susceptibility. 1 plus magnetic susceptibility. Magnetic susceptibility is 100. So 1 plus 100 is 101. So that should be the relative permeability, which is 101. Option C. How many of you gave it? Very good. Sound instincts. Oh, some of you gave the wrong answer. See, everybody gave weird answers. Nigesh, very good. Oh, Nayana, no, it is wrong. Yeah, C it is. Be careful, guys. Yeah. Okay. Next, if magnetic object is placed in a magnetic field, what do you think happens to that particular thing? Following substance moves out of the field. Who does not like? Who does not like the magnetic field? Dia. Go die, man. I don't like you. Go die. So diamagnetic, yes, diamagnetic always hates the magnetic field. It will go out. Yes. Computer science, Sampath. Who else? Namrata ma'am, of course. Next. Wow, we have matched the following. Diamagnetic, para and ferro. Dia means worst fellow. Dia, go die. Para is like, okay, somewhat okay, good. Ferrero Rocher. Everybody loves Ferrero Rocher, right? Very yummy chocolates. Yes, international chocolates. Correct. So Ferrero is the best. Dia is like the worst. Para is like okay. So diamagnetic. What do you think is the answer, guys? Yeah, permeability is less than mu naught because relative permeability is less than 1. So A is going to P. Paramagnetic. Paramagnetic susceptibility is more than 1. Domain is related to Ferrero Rocher. Yes, ferromagnetic. So C with Q, B with R, A with P. A with P, B with R, C with Q, option B. Yes, check this. Option B. Wow, sound in the strings. Great. No, Nati, it is not D. Ravi, it is not D. Nigesh, correct. Thank you, Ruzian. Very good. Slayer. Awesome. Moving on. If you take a compass needle of magnetic moment M, it's put in a field of uniform value B such that the angle is theta, the ratio of the torque to the energy is. Wow, lovely question. You know the formula, directly substitute, you will get it. You directly substitute, you are going to get it, my dear students. Nothing great in this question. What is the formula for torque? What is the formula for torque? And what is the formula for energy? Torque is mb sine theta. Energy is mb cos theta with a negative sign. But they have asked the magnitude. Magnitude only. So negative sign is ignored. MMBB cancelled. Sine by cos is nothing but tan theta. C for whom? Captain Shreyas. Yes, you can find me on Instagram and Telegram. That's my Instagram handle. C for your captain Shreyas. Correct. Very good. Moving on. The following diagram shows a magnetized needle P which is placed at point O. Can you see this magnetic needle? It is placed over here. It is pointing up. The arrow shows the direction of the moment. The other arrow shows the positions and the orientations of the another magnetized needle Q. So this is one needle pointing upwards. You have taken other needle. First you have placed here, then you have placed it here, then you have placed it here, then you have placed it here, here. So many different 6 positions, 5, 6 positions are there. Which is false? Which is false? Come on, everybody. Remember, when you talk about energy wise, if the magnetic moment and the magnetic field are in the same direction, then it is in stable equilibrium with less energy. But if it is in opposite direction, it has more energy. So Q4 and P are opposite, maximum energy unstable. P and Q6 minimum energy stable. Then if you look at Q5 and O also, same, no. From here the field will go like this. The magnetic field will go like this, opposite. So this is opposite, guys. So Q5 is in unstable maximum energy. Then Q3 minimum energy, because from here the magnetic field will go like this, field and moment in the same direction. Whereas Q1 and Q2 energy will be zero, because the magnetic field will be going perpendicular to the magnetic moment. So Q1 and Q2 zero energy. So, oh, I think the answer is already, by mistake I clicked the next slide. PQ6 corresponds to maximum energy. PQ6 corresponds to maximum energy is false. The question says false. Actually, PQ6 corresponds to minimum energy, because they are in the same direction. Yes, they correspond to the same direction. See, basically you should know, if field and moment are in the same, minimum energy stable, opposite direction unstable, and perpendicular means zero energy. Use the formula minus mb cos theta. Yeah, that's the formula. Minus mb cos theta. What's the unit of flux? Oh, come on. You should be able to get it. Come on, come on, come on, come on, come on, come on, come on. Everyone. Yes. Oh, PDF will be available tomorrow. So don't wait for the PDF. That's why I have made the session for all of you. Yep. What is it? Tesla meter square, which is also called Weber. Yes, Weber is the unit. Remember, just few moments back, we did the unit of electric flux. Electric flux was completely different. Magnetic flux is Weber. Don't ever get confused. Weber is not for flux every time. It's only for magnetic flux. Okay, moving on. The dimensional formula of inductance. Inductance. How do you get the dimensional formula? This is one of the most popular question. See guys, energy in an inductor is half Li square. So inductance is 2 times energy by current square. So if you now go unit wise, the unit of inductance will be 2 is dimensionless energy. So you have energy on the top, and then you have current, then you have current, and then you have square of it. So basically energy is nothing but mass raised to 1, length raised to 2, t raised to minus 2. That's the dimensions of it. This is current, current is ampere, and this is square. So this will just become m raised to 1, l raised to 2, t raised to minus 2, and then you also have a raised to minus 2. So that's the answer. Where is it? Where is it? Option A, B, or C, or D? Option A, B, or C, or D. So this is a raised to 2. I should get a raised to negative 2. So I think it should be B option. Yes, it is a B option. So if you remember the formula of energy, it becomes very easy to get the dimensional formula. Next, inductance of a coil is not dependent on which of the following. It is not dependent on which of the following. Come on, what do you think? Is independent of geometry? No, it depends. Current? That is the answer. Medium? It depends. Number of turns? It depends. It is the current through the coil which it is independent of. Correct. It should be B option. It depends on C, A, and D. Okay, it depends on. I think the answer marked here is wrong. Ignore that. The correct answer is the current. Current is the wrong answer. No, not A. Yeah, it is B option. B option. Yeah. So if you change the material inside, permeability changes. In fact, the formula is mu naught n square Al. So A into L means geometry. Mu means medium. Number of turns means n square. So current is never there only in the induction formula. Okay. So it is not C, it is B. Okay. current through a coil is doubled, the energy stored will be, what's the formula? Half L I square, right? What is the formula? Energy stored inside an inductor, half L I square. So if I double the current, meaning 2I square, so what will happen? This will become 4 times energy, because square of 2 will be 4. So it will become 4 times, isn't it? Oh, yes, correcto. It will become 4 times. So B for Baswa, sir. No, not C, my dear. It is B option. It will become 4 times. You gave it wrong. Okay, moving on. The angular speed of rotating armature of a generator is increased. If you increase omega, then what do you think will happen? Both the frequency or EMF, what do you think? Peak EMF, what do you think will happen? If you increase the frequency, angular speed, frequency will 100% go up. What about the EMF? That will also go up, because remember that formula for EMF is B A omega n, and omega is 2 pi f. So if you increase the angular speed, frequency will also go up, omega will also go up, EMF will also go up. So both frequency and the EMF should increase. B A omega n, Bohr-Born. Remember this, or Born identity. That's how you are going to remember. Bohr-Born biscuit or Born identity. Born, B A omega n, W is omega. Yep. Next one. Which of the following is wrong? AC can be stepped up, step down. It is economical. Average value is 0. Average power for AC may not be 0. What do you think? One of them is wrong. One of them is wrong. Born Identity, Nigesh. Yes, completely goat movie. I loved the entire series. Yeah. I think I can already see it is definitely not economical to give DC for large distance. That's the reason why we use AC for power transmission. At the power station, the AC voltage is converted to high voltage, low current, so that I squared R losses are less, transmission losses are less. In fact, the advantage is AC can be easily, efficiently stepped up, stepped down, and can be transmitted to a large distance with minimal loss. DC, on the other hand, it's very difficult to convert, change the voltage. So in fact, this is wrong, B option. Average value of a voltage is 0, because whatever positivity is there, same negativity will be there. So in the entire cycle, the positive negative cancel and become 0. Last one, power may not be 0, because the formula for power is voltage into current into cos phi, where cos phi is the power factor. So the power factor is 1, it is maximum. Power factor is 0, then there is no power loss. So it depends on the power factor. Correct. Very good. Yeah. All right. Ayo, it's okay. See, some people will spam, some people will try to distract you. And I also started seeing some random people, some YouTubers also coming and spamming, because sometimes people don't like people succeeding, either the teachers or even the students. So you have to learn to deal with that in life. Just like you will always find some batchmate of yours always try to deceive you, always try to fool you. Hey, don't study. I am also not studying. But you know what? That student will be actually sitting and studying at home. And suddenly his or her marks will be more. So sometimes students will chumma try to, hey, watch that movie, very nice movie. They will not even tell you what they are doing. Same thing also happens even for teachers. Sometimes, we also get that hate from somebody who is probably not liking the way, we are becoming slowly popular. We are loving, we are getting love from all of you. So you need to learn to ignore that, because we are much more than that. We have come here with only one single intention, to benefit our students in Karnataka. That's all. Okay. The dimensional formula of LC is self-inductance, C is capacitance. Oh, come on. LC. It is straightforward, guys. Yeah. Come on, come on, come on, come on, come on, come on, come on. Come on, come on, come on, come on, come on. What is it? There is a formula, guys. I don't know. You remember resonant frequency? Resonant frequency is 1 by 2 pi root LC. What is frequency? 1 by time period. 1 by time period. Oh, so the dimensional formula of time is the same as LC's root. LC's root. Because this is denominator, this is denominator. So dimensional formula of T square will be the dimensional formula of L into C. Yes, L into C will be same as T square. So where is T square? T square is option B. Got it? Yeah. So this was your resonance concept. Concept of resonance was used. Concept of resonance. Frequency is 1 by 2 pi root LC. Frequency is 1 by time period. Perfect. B is the correct answer. Frequency of AC is increasing. Impedance will, what will happen to the impedance? What will happen to the impedance? Again, the concept of resonance. If you remember the resonance curve, you will get it, guys. Yeah, please focus. Yes, yes. Derivations already done. Already done. You guys don't see the channel, I feel. Guys, you don't see the channel or what? See, videos. What is this? All physics derivations. 6 hours video. I have kept it for you. It's there. Just 5 hours ago, we have updated it. Please start seeing it. And once you see, no, don't be so confused also. Smash this like button. See, so many people see, I feel bad that you guys chumma watch the classes, but you don't even have that thing. Okay, I should at least like, I should subscribe. Smash that like button, guys, and subscribe to the channel. I will feel happy for the hard work that we all put in over here. Okay? Yeah, do that. Thank you so much. Okay, moving on to the next one. What do you think? The correct answer is first decreases and then increases. That is correct. Very good. And I'll tell you why also. Because if you remember, current versus frequency, the graph goes like this. So current is maximum at resonance. So impedance should be basically minimum. So first it decreases, then it increases. If you draw for impedance versus frequency, because current is voltage by impedance. Current is voltage by impedance. If current increases, impedance decreases. If current decreases, impedance increases. It's complete inverse relation. So decreases and then increases. Got it? Clear? Resonance curve. Yeah, very good. Let's go to the next one. Let's go to the next one coming up on your screen. Okay. If you take a transformer, the turns ratio is 100. What does it mean? What does it mean? Secondary by primary is 100. That means the secondary voltage will be 100 times more, or the current in the secondary will be 100 times less. One and the same thing. So the input current is 100 times the output current. Perfect. Because here the voltage will increase 100 times, but the current will decrease 100 times. They are inversely related to each other. So the input current will be 100 times more than the output current, because output current will be 100th of the input current. Got it? Option D. Very good, Sanjeev. Awesomeness. Yeah, can we use the formula? Nigesh, that will be very lengthy. Don't use the formula. It is better to use the graph. It is much better. Cool. Let's go. Okay. Column 1 lists the components through which AC is passed. Column 2 lists the is related to column 1. Match the columns. Resistor, capacitor, inductor, series, LCR. Come on, guys. Pure resistor. What happens? The current is in phase with the voltage. Correct? Current is in phase with the voltage. So what do you think is the correct answer for this? For A, reactance, current. Yeah, the reactance is independent because the resistance is not even dependent on omega. So it is independent. So A goes with R. For a purely capacitive circuit, for a purely capacitive circuit, for a purely capacitive circuit, current is ahead of the voltage by 90 degrees. Yes, current is ahead, current is horizontal, voltage is below. Current is ahead of the voltage. Current is horizontal, voltage of a capacitor is below. So current is ahead of the voltage by 90 degrees. So B goes with P. Inductor. Inductor. Current is behind the voltage. Perfect. Exactly opposite. Series LCR, average power may be non-zero. So D goes with S. So in LCR circuit, power is VI cos phi. So it could be anything. So this is the correct answer. Perfect. Next one. Ready for it? Ready for it, my dear warriors? Yeah. Let's go. The following figure represents voltage, current, AC with time. Solid line represents voltage while dash represents current. So this is voltage, the solid, and the dash, the dotted one, is current. So what do you think is this? Definitely it has some phase difference. Can you see when voltage is 0, current is already having some value? In fact, current reaches the maximum before the voltage. Current is ahead of the voltage. So this can only happen if this is your current is ahead of the voltage like this. Remember, this side is capacitive side, this side is inductive side, this side is inductive side. So what do you think is the correct answer for this? What do you think is the correct answer for this? Yes, because the voltage is behind, and you can see that right over here, when the voltage is 0, the current has already reached some value. The voltage has not yet reached the value, it reaches after the current. So voltage is lagging, the current is basically leading. Yes, that's the phase difference. So that means it is more capacitive than inductive. So capacitance is more, inductance is less, definitely reactance wise. So option D should be correct. Option D should be correct. Very good. Excellent, guys. Proud of all of you. Proud of all of you. Okay. Displacement current. Come on, we have already reached the electromagnetic waves chapter. Come on, my dear students. Yeah. What do you think is the correct answer? Displacement current is produced because of, see, there are two currents. Conduction current means the actual current which flows because of the motion of the charges. Displacement current, there is no actual charges, but it is a changing electric field which creates that. It's there in electromagnetic waves chapter. Yeah. Oops, sorry, this is not the correct one. Changing electric field. Option B. Option B. Not changing magnetic field. Changing magnetic field, that concept is there in EMI chapter, that produces electricity. But the question is displacement current. Yeah, be careful. It is changing electric field. Got it? Everyone? Very good. Moving on, next question. Expression for the displacement current. See, how quickly your electric flux changes, electric field changes, decides how much the displacement current is. Direct formula, d phi by dt is there. I don't think epsilon naught square is there. Mu naught is also there. Epsilon naught is also there. Or only one of them is there. Only one of them is there. And that is none other than, ayo, what happened? Yeah. Come on, guys. What is it? Option B or option D? Option B or option D? Yes. Come on. Be careful. It is not option B. Here answer marked is wrong. Yeah, it is option D, guys. Remember the formula for your displacement current in amperes loop form is magnetic field dot dl is mu naught conduction current plus displacement current. That displacement current is epsilon naught d phi by dt, but this is electric flux. So the displacement current formula is option D, guys. This is not correct. Okay. So a lot of people make that mistake. It is not B option, it is a D option. Yep, be careful. Yeah, it is not B, it is D option. I'm showing you the formula also. See, this is the formula. Conduction plus displacement. This is Ampere's law modified in electromagnetic waves chapter. Okay, ignore that D option, it is D. Okay, next. EM wave is going through vacuum. This is the electric field equation, magnetic field equation. Which of the following is correct? This is again formula based. This is again formula based. Ari, please check my strategy video which I have made. Yeah, how to score 70 out of 70 strategy video I have already made. Guys, the velocity of light is electric field by magnetic field, which by wave parameters is omega by k. So, E naught k cross multiply is B naught omega. So, is there some equation which is valid? E naught k is B naught omega. Who is this? C. C means Captain Shreyas. C for Captain Shreyas. Nothing else will match. Everything else is wrong. Angular frequency by angular wave number is wave speed, which is also electric field by magnetic field, which is also 1 by root mu epsilon. All these are correct formulas. I have discussed this in EM waves. wavelength of X-rays. Now you'll be like, sir, I don't remember these values. Is there a trick, sir? Well, I'll tell you. See, X-rays are used to detect the crystal structure using Bragg's law by diffraction. And diffraction occurs when the wavelength is close enough to the interspacing of the molecules or the atoms. Now, the intermolecular distances are in few Armstrongs, which is like a nanometer, zero point 0.1 nanometer, 0.01 nanometer, like that. So, it is lesser than a nanometer, the distance between the atoms. And when X-rays pass through those space between those molecules and atoms, they get diffracted. Studying those diffraction patterns, you can identify the crystal lattice structure. So, X-rays have the wavelength similar to the atomic spacing, which is none other than the nanometer range, smaller than a nanometer, 10 to the power minus 3 Armstrongs. Very good. Excellent. Awesome. Moving on to the next one. Infrared plays an important role in maintaining the temperature. Infrared are sometimes referred to as heat waves. Is this correct? Come on. If you know it, you know it. Yes, it definitely is called as a heat wave. Infrared radiation is emitted by humans and even the earth. You can say that the heat gets bounced off and it is getting trapped. So the global warming, etc., is based on this infrared radiation. Yes, gaming zone, ಸ್ವಲ್ಪ ಕನ್ನಡ ಬರುತ್ತೆ ನನಗೆ. Yeah, infrared radiation definitely is called as a heat wave and it plays a significant role in our climate, in our global average temperatures. Okay, so definitely that is the correct answer and it is the explanation also. Microwaves are used in microwave ovens. Is it correct? If the frequency are matched, resonant frequency water molecules. Oh, is that right? Is that right? Come on, come on, come on, come on. Guys, the name itself has the answer. Microwaves. Where did the name come from? Microwave oven. The name came from microwaves because microwave ovens use microwaves. Why microwaves? Why not infrared or ultraviolet? Because the microwaves, when they enter the food particles, there is some water in that water content. A rice, chapati, whatever you eat has some water in it. So those water molecules, they start to oscillate because their frequency of oscillation matches the frequency of microwaves. That means frequency matching, which is called resonance. So because they vibrate, they produce thermal energy, and that's how your food gets cooked. That is also mentioned as a special paragraph in your NCRT. So if you open and read it or see my NCRT sessions. So definitely it is the correct reason, and that is the reason why you use microwave in microwave ovens. Because to heat the food, you want the microwaves to resonate with the water molecules, and when they resonate, they vibrate and they produce the thermal or heat energy, thus ending up heating the food, which is the purpose of a microwave oven. Oven means heating. Yeah. Okay. When an object is placed at an infinite distance from a mirror, the image is formed direct. Everybody spam the answer. Okay, thank you. Ruzian, thank you. Very good sound, the strings. All right, come on, come on, come on, come on. Everybody spam the answer. Where do you think it is going to be formed? Object at infinity, image is formed always at the focus. That's the definition of focus. Yeah, just like you should be focused right now on the session. The rays converge at the focus. That's the definition of it, not the center of curvature. The speciality of center of curvature is if a ray passes through the center of curvature, after reflection, it will again pass through the center of curvature. That's the reason why an object placed at the center of curvature, the image is also formed at the center of curvature. Okay, just that the image will be inverted. That's all. Next, in refraction of light, ayo, come on, guys. This is very simple. Laddu question. Laddu question. Yo, come on, come on, come on. Break beda. Yes, Aishu. Break sigalla. Yes. I hope my Kannada was correct. Break sigalla. Why? Because We are more than 60-70% of the session done. Come on, guys. Yes. Sin I by sin R. Snell's law. Very good. I was waiting for everybody to spam. At least easy questions you should give. No. That also you want me to do. Okay. Lenses are in contact. What is the power of the combination? Combination of lenses. Combination of lenses. Okay, sir. What is the answer? See, the effective power is a P1 plus P2. What is P1? 1 by F1. What is P2? 1 by F2. LCM, LCM Togoli. F1, F2, this will be F1 plus F2. So this is the effective power F1 plus F2 by F1, F2. B andre Basvasaurus, sir. Yes. Okay, very good. Very good. Very good. Sir, I am your teacher. Oh, you are my teacher. Which teacher? Dance teacher? Show me your dance moves. I would love to learn more dance from you. Hmm? Because I don't have any other teacher right now. Okay. Magnification of refracting telescope. Ayo, this is simple. Macha, come on. Simple answer is there. Yeah, Adi too, there will be a separate numerical session. I read all your comments and definitely there will be. Okay. Yeah, what is it? FO by FE, FE by FO, FO plus FE, FO FE. Ayo, sir, what is this? FO, FE, F? So much F, sir. Too much of foul language. What is the correct answer? This is the length of the tube, FO plus FE. This is not even a formula. Is it FO by FE or FE by FO? O by E or E by O? It is. It is O by E. Yeah. OE, not EO. It is not EO, it is OE. Remember that. Telescope. Yes, telescope. Last E is there. So last E means E is given least preference, so it is down. Chumma one random logic. This is not even some good logic. Chumma one way to remember. Telescope. O, 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 P, E. O on the top. O, P. O on the top. E in the end. OE. Got it? Fine. Ray of light is incident on some interface at an angle greater than the critical angle. What do you think? The angle of incidence is more than, is more than, is more than. Come on, come on. See, some of you loved my logic. Yeah, come on, guys. What do you think? What do you think? Is greater than. Then the ray will undergo total internal reflection. If it is less, it will refract. If it is more, total internal reflection. If it is exactly equal, if it is incident at the angle greater, then it will reflect. If it is equal, then it will graze the surface. So the correct answer is total. Ayo, this answer is wrong. So many answers are marked wrong. So total internal reflection, guys. Got it? B for Basvasaurus. Very good, Pooja. Sanjana, Adi, Rutu, Chinu, Chiru, Zen. Very good. Kumar, super. Sakkat. Guys, loving the session. So comment Sakkat. Yes, I want that Sakkat answer in the chat box or in the comments after the session is over. Sir, session was super Sakkat, sir. SS. SSS. Shreyas. CSSS, I should put maybe. Captain Shreyas Sakkat Super. Super Sakkat. Okay, great. This is not D, that was B option. Okay. A convex mirror is preferred over a plane mirror in vehicle. Oh, everybody drives some vehicle, you would have seen. Convex mirror is used. Why do you use convex mirror? To observe the traffic coming from behind, obviously. No, from behind only. Why will you see traffic from front? You have your eyes, no, for that. Why will you see using a mirror? Convex mirrors have a large view field and real objects are erect. Correct. Very good. That is exactly the reason. Okay. My hair cutting is sakkat. Oh, thank you. Yeah. Thank my barber, not me. My barber was good. And 100 rupees he cuts. I don't go to fancy shops. My barber, no, very cool he is. 100 rupees he takes. And if I pay him 50 rupees more, nice polish he does, puts nice oil. Super duper massage. Before I went paying some 500 rupees to one saloon. Nothing. They just gave me AC and they gave me very good water and they gave me tea coffee. Haircut means, are you looking like one, yeah, Bandipur jungle fellow only. Yeah, looking like an animal. So then I realized, oh, you have no point paying 500 rupees to this saloon. I will, that too only for one simple haircut. Then for hair wash, again some 200 rupees. And then what is that? For if you ask head massage, gone only. Yeah, I have to park my vehicle only over there, donate it. So yes, both are correct, but it is two is the correct explanation. Oh, ayo, B option says it is correct. A option says it is not correct. It is the correct explanation. It has got a good field of view. That is the reason why you use it. So it is explaining it correct. Yeah. Yeah, Bangalore influence. Yes. The focal length of a equiconvex lens of a refractive index 1.5 is placed in air is equal to the radius of curvature of either face. For equiconvex lens, radius of curvature of both the faces is the same. Okay, this is fine. But is it the correct explanation? Equiconvex means both the radius will be the same. That is correct. But what about that? The focal length. Okay, use the lens maker formula. 1 by f, refractive index is 1.5 minus 1. 1 by R1 minus 1 by R2. Sign convention makes that negative. 1.5 means 3 by 2 minus 1 is basically half. Okay. Minus minus will become plus. So 2 by R. 2 cancels. So it will become 1 by R is 1 by F. So that means focal length is the radius of curvature. So the focal length is the radius of curvature, correct? This is also correct. But how is it explaining it? The explanation is not very clear. I mean, the explanation will come from the lens maker formula. So I think they are correct statements, but they are not explaining it. But it is not a correct explanation. It is not a correct explanation. Okay? Yeah. Kumar, what do you mean by do MCQ? This is MCQ only, no? Hmm. Yeah. What do you mean by do MCQ? Yes. Sure. Let's go. Let's go. Let's go. Cathode ray particles means what? Cathode ray. Cathode ray. Remember cathode rays. What are cathode rays? Proton, electron, alpha or neutron. If you know it, you know it. Cathode rays are basically what? Protons. What is cathode rays? Come on, super sir. Come on. Yeah. Don't worry, Sanju. Check out my strategy video. Yeah. Yes. Check out my strategy videos. All right. I have made it yesterday only. Yeah, for 70 out of 70. Electrons or protons? No, it is not protons. It is electron. Electron, ayo. Yeah, cathode rays are electrons. Keep it in mind. Cool? All right. All right. Great. Moving on to the next one. If you give enough energy for an electron to overcome the pull of a metal, what is that energy called? You go visit your friend, you convince their parents, please send me, send that person with us, we will take care of him. You have convinced the parents, please let him go with us. Same convincing light will do to the metal. Please let that electron go. Please leave that electron, let him come out. So that convincing happens by the photons, and the atom is like, okay, take it out. So that energy required to pluck out that electron is called as the work function, isn't it? Yes, it is the work function, option A. How many of you said option A? Option A. Very good. Who is that? Kushi. Is that you who answered it first before? Yeah. Okay. All right. All right. Very good. Very good. No, it is not B. It is option A, guys. Option A. All right. Very good. Next question. Next question coming up on your screen. The graph of photoelectric current versus intensity is if the frequency is more than the threshold. When you increase the intensity, the current also increases proportionately. So current is directly proportional to the intensity. So it will be a straight line. Straight line. With passing through the origin. Why origin? Because when there is no current, no intensity will be there. No light will be falling. How can current come when there is no light falling on a photoelectric setup? So the graph has to pass through origin because when there is no light, then there is no current. The option A says with an intercept, which means even when there is no light, there is some current, which is wrong. Current versus intensity graph will pass through origin. Yes, these kind of questions, meaningful, will come in your board exams. Cool? Yeah. The absorption of light energy by the retina of the eye is described by absorption of light is described by which of the following? See, the concept of momentum, the concept of collision, concept of striking, feeling something, or the concept of absorbing something, these are the properties of particles. Whereas bending of light or spreading of light, these are the concepts, or interference of light, these are concepts associated with the wave nature. So absorbing something means it has touched it, you have felt it, it has got absorbed. That is the particle nature of light, not both. It is not wave. Yes, it is B for Basvasaurus, sir. Yes, very good, very good, very good. Awesome, nice. Next, the following statements relating to the wave theory explain photoelectric emission. Maximum kinetic energy is proportional to the intensity. Frequency of radiation does not depend on the photoelectric emission. Come on, guys. Come on, come on, come on, come on, come on. Is it the correct explanation? Maximum energy proportional to the intensity of the light. Is that so? What do you think? Maximum kinetic energy is proportional to the intensity of the light. Yeah. Come on. I don't think so. Definitely A is wrong. I mean, the formula for kinetic energy goes like this. HF, frequency, is work function plus kinetic energy. So kinetic energy is rather dependent on frequency. It is not dependent on intensity. So one is false. Frequency does not depend on the photoelectric emission. The frequency of radiation does not depend on the photoelectric emission. Guys, the frequency actually depends on that photoelectric emission. Rather, what electrons are emitted are going to be decided by what photons are going to be falling on it. If the photons are more energetic electrons will come out of it. So they do not depend is also wrong. So option D is the correct answer. Option D is the correct answer. Many of you got it correct and some of you also got it wrong. Shravani, correct. D answer is correct. Very good, Manogna. Nayana, Rutu. Very good. D. Hi. Yes, 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 yes. Awesomeness. Awesomeness. Oh, yo, this answer is also marked wrong. D answer is correct. Okay. Moving on to the next one. Correct, coming up on your screen. Graph momentum versus the de Broglie wavelength. Direct formula based question. Know the formula, you will get it. Gopika, separate session for numericals coming very soon. Yeah. Okay, come on, guys. What is the correct nature? Momentum and de Broglie wavelength. Ayo, where is it? De Broglie wavelength, the formula is h by p. That means the de Broglie wavelength is inversely proportional. This is straight line direct. This is not inverse. This is also not inverse. It has to be a curved line. It has to be a curved line going like this. So option D is correct. Option D. Very good. D for Diksha. Correct. Excellent, guys. Very cool. Next, if you take a photoelectric experiment, the wavelength of the light is reduced from 6000 to 5000. Oh, what do you think will happen to the frequency, potential, energy, value of the work function? One of them is the only correct one. Think about it. The formula is if you reduce, if you if wavelength reduces, frequency will increase. So frequency will decrease, wrong. Then hc by lambda is a work function plus maximum kinetic energy. So if wavelength reduces, the ratio will increase. So maximum kinetic energy will increase. Also, kinetic energy is given by E into Vs. So stopping potential will increase. So B option seems to be correct. Kinetic energy will decrease is wrong. It should increase. Work function is not even dependent on it. It only depends on the material. Nothing else. It only depends on the material. So this is also wrong. So option B is the correct answer. Yes, correct. Very good. Awesomeness. Very nice, guys. Very nice. Very nice. In a photoelectric equation, the slope of potential versus frequency. This is a very good question. Come on. If you remember the graph, you will remember it, or else gone. Else gone. There is this graph. You have stopping potential, and here you have frequency. And that graph looks something like this. Dotted line, and this is like this is F naught. What is that slope? That slope is always h by e. That slope is always h by e, and this intercept is always minus work function by e. Yes, this is how this graph is. The slope is always constant irrespective of the material that you choose. So it is h by e is the correct answer. B for Basvasaurus. Very nice, very nice, very nice. Moving on to the next question, guys, on your screen. Alpha particle in your Geiger-Madsen experiment is the source of alpha particle. Yes, Davison-Garmer, all this experiment. Where do you think that alpha particles comes from? Yes, come on, guys. Even the Rutherford experiment, it comes from an element called as bismuth 214, which is radioactive. Yeah, radioactive. Got it? Moving on to the next one on your screen. What is the thickness of the gold foil in alpha particle scattering experiment? Yes, the gold foil. It is very, very thin. It is very, very small. But how thin exactly is it? You should know the value. It is very, very small. It is of the order of 2.1 10 to the power -4 millimeter. Yeah. Option C. Option C. Cool? Yes. Awesomeness. Moving on to the next one. Next one. The detector in alpha particle scattering experiment is coated with. That alpha particles get scattered by that gold foil. Most of them go as it is, few of them deflect by small value, very, very few will bounce back with 180 degrees, almost opposite. So you detect those alpha particles by a coating of zinc sulfide. Yeah. Yes. Oh, come on, zinc sulfide. Yes, 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 yes. Moving on to the next question coming up on your screen. D option. Yes, D for Diksha. Very good. Next question. Emission line spectrum is characteristic of those lines of emission. Those lines of emission that you get, they are characteristic of what? Molecule, solid, atom, a liquid. What do you think? The emission line spectrum, what is it a characteristic of? Very direct question, guys. Very direct question. Very direct question. Oh, you D for Dagar. No, no, no. Come on. Every element has a specific characteristic. Element means molecule or atoms. It's not, sorry, not molecule, an atom. It's a characteristic of the atom, the element. Yes, C for Captain Stress. Oh, sorry, it is not D, guys. It is C for Capto. C for Captain Stress. Correct. Every element, every atom has a unique signature. Like you have a sign, signature is there for the atom. Okay, so it is not D, guys. It is option C. Okay, moving on to the next one. For the Bohr's radius, the principal quantum number, guys, Bohr's radius, that means ground state of hydrogen. Ground state of hydrogen is Bohr's radius. So K shell means n is equal to 1. So if n is 1, n square will also be 1 because 1 square is 1. So I think it should be C option. Yes, very good. C for Capto, C for your Captain Shreyas. Awesome, guys. Awesome, awesome, awesome. Very good. Moving on. The first orbit is 0.53. The fourth orbit will be, oh, what is the radius proportional to? The radius is proportional to n square. So basically R4 by R1 will be 4 by 1 square. So therefore R4 will be R1, which is 0.53 into 4 square, which is 16. 0.53 into 16, guys. 16 is half. Come on, approximately will be 8 point something. So I think this will be like 8.48 roughly, around that. Yes, 8.48, option D. Yes, Bega Hedi. Yes, option D for Diksha. Very good. No, it is not C. It is option D. Very good. Excellent, guys. Moving on to the next question. According to the theory, electron will fall into the nucleus. Accelerated electron emits radiation in circular path. Bohr's model, try to remember it. When you go from Rutherford to Bohr, this is where that particular theory will come. Come on, come on, come on, my dear students. Try to remember it. Try to remember it. Everyone, what is the answer for this? Yeah, the electron will fall into the nucleus. That is classical theory. Correct. The accelerated electron emits radiation in a circular path. Definitely, when you go in a circular path, you are accelerating it. It should emit it. So both 1 and 2 are true. And the second is the explanation of the first. Yes, when you accelerate a charged particle, according to Maxwell, there will be Maxwell's radiation. And that radiation causes loss of energy. Because of the loss of energy, eventually the path taken by the charged particle will be a spiral path, not a circular path, and eventually it will collapse and it will fall into the nucleus. So that was the failure of Rutherford's model based on classical theory. So then we go to the quantum theory given by Bohr. He says the orbits are quantized, energy is quantized, angular momentum is quantized. You cannot randomly go around. They have to be in specific numerical integral values only. So that quantization theory was given by Bohr, which was an improvement over the Rutherford model. Hydrogen is raised from ground state to excited state. Oh, come on, come on, come on, come on, guys. This is very important question. Yeah, it is completely formula based question. So what happens is that you should know the formula. The energy is given by negative 13.6 z square by n square. Not just that, you have the potential energy given by 2 times of the energy and the kinetic energy given by the negative of the total energy. Negative of the total energy. So let's understand what exactly will happen. If you go to the excited state, n will go up. So this value will reduce. So from more negative, so maybe from 13.6, you might become minus 2 point something. So what is happening? You are increasing the value. You are increasing the total energy. Agree or not? From more negative, you are becoming less negative because that numerical value will reduce. Forget that negative sign. If denominator increases, the numerical value, mod value will decrease. So when you put negative number, so minus 13 will become 2, 3, 4, something like that. So minus 2 is more than minus 13. Agree or disagree? Yeah, in negative numbers, it works the reverse way. Correct. So if it has become more, that means potential energy also has increased, but kinetic energy is negative of that. So kinetic energy would have decreased. So kinetic energy decreases, potential energy increases. So potential energy increases, kinetic energy decreases, which is option A, not C. Yeah. Priyanka, why 20 out of 20? The paper is of the paper is of 70 marks. Why are you aiming for 20 marks? Hmm. Okay, next. Isotopes are atoms having isotopes. This you learn it in chemistry also. Yeah. You will get full 70 out of 70 if you follow proper strategy. That's all. Okay. You have to target for 70. See, if paper is difficult, okay, maybe everybody will get 50 marks, 60 marks. But it's okay. At least you will be in that 50, 60 marks zone. If paper is easy, then everybody will get 60, 70 marks. So then you should not be at 40, 50 marks. So if paper is genuinely difficult for everyone throughout Karnataka, no issues. Maybe the average score will be 30, 40 or 45 marks. Then you should be in that higher zone. Got it? Don't be in that lower zone. Oh, sir, paper was difficult. I failed. I got 5, 10 marks. No. You should at least get 30, 40 marks, 45 marks. Right? Okay. What do you think? Yeah, same number of protons, but different neutrons. Atomic number will be same. Atomic mass number, which is then different because of the neutrons, more neutrons or less neutrons. So that is isotopes. Radius is proportional to A raised to what? Standard formula. A raised to what? What is that power? Cube root, right? Cube root of atomic mass number. Yeah, cube root of atomic mass number. Density is always going to be the same. It is not even dependent. That derivation is there. So keep that in mind. It is independent of the atomic mass number. Binding energy of a nucleus is binding. When you want to hold things together, you bind them. So what is binding energy of a nucleus? A for Appa. Yo, Kushi, what an interesting thing. Binding energy. To bind the people, you will see the energy will be released. So when you want to break them, you will give that energy, what was released, and you will be able to break them. So whatever energy was holding them, you give it to that nucleus, it will break into small particles. So energy required to break the nucleus into constituent nucleons. Nucleons means protons and neutrons together. So you break it into individual particles. Yes. So the total, no, it is not the total kinetic and potential of the nucleons. That is wrong. Who said that? Total energy of electrons and kinetic and potential of the nucleons. That is wrong. D is not correct, Suresh. Yeah. B for biryani. Ayo, don't make me hungry, da. Yeah. Okay. What is the next one? Radioactive object will emit alpha, beta, gamma, or all of the above. Radioactive, what do you think it will do? Oh, Baswa sir is here. Yes. Baswa sir is saying if you are new, then please subscribe. Come on, guys. See, Baswa sir has to come and tell you means it is shame on you. Yeah. Is it something to be told? You have to do it. Baswa sir will feel bad then. Baswa sir is already waiting for his turn for biology paper, guys. So by biology paper, no, you should at least make this channel really popular. I mean, if you're not making it, then we have to think whether we should help you for KCT or COMEDK. Yeah, it's really serious. I mean, come on. We should think, no, that if you're not making us famous, then okay, maybe fine, we will not work for KCT then. Yeah, alpha, beta, gamma, or all of the above. Very good, all of the above. All the three things will come. All the three things will come. Awesome. Correct. Very good. Moving on. What is the mass energy equivalent of 1 AMU? Standard formula. One atomic mass unit when destroyed, which is basically you take 1/12 of a carbon atom. That is the one atomic mass unit. You destroy it, use MC square formula. You get a total energy in electron volt of 931 mega electron volt. 931 mega electron volt. 1 AMU, which is 1/12 the mass, is 1.67 10 to the power minus 27 kg, which is roughly the mass of a proton or neutron. Almost similar. Yeah, almost the mass of a proton or neutron. D option, D for Diksha. Everybody told this. Ayo, very good. Next question. Nucleons are at this much separation. Net force between them is F1. If both of them are neutrons, then it is F2. If both of them are protons, then it is F3. Sorry, force is F1 if both are neutrons. It is F2 if both are protons. F3 if one is proton, one is neutron. In such a case, what is the best correct answer? Come on, guys. Straightforward. If both of them yeah, come on, guys. They are very close to each other. See this femtometers. So who will dominate? Who will dominate? The nuclear force. And nuclear force between neutrons and between protons are similar. And also one is proton, one is neutron. The charge, how will it matter? Charge has nothing to do with it. If the distances are same and it is in femtometers, yes, it will be very similar to each other. It should be C option, guys. Yeah, the electric force will become negligible at this distance, right? At femtometers, nuclear force will dominate. See, you guys are thinking, sir, proton will repel. No, sir. Proton, neutron, nothing will happen. No, sir. No, ignore that electric force. Electric force will not be even considered at such a small distance. Nuclear force will overpower. OP it will be. Yeah, got it? Next, fusion reaction. Which of the following is fusion? What happens in the sun? Come on. What happens in the sun? What happens in the sun? Come on. Purnima, which one you want me to solve? Yes. Fusion. Hydrogen becomes helium. This is not fusion. This is neutron collision. This is fission. This is isotope of hydrogen, radioactive. It is decaying. So D is fission. This is fusion. This is neutron bombardment. B and C, they are neutron bombardments. Yep. So, yep, that is the correct answer. Hydrogen becomes helium. Semiconductor with donor. Donate. What do you donate? You donate an electron. And when you donate an electron, it becomes N type, negative, N for negative, electron negative. If you have acceptor, acceptor means there is vacancy. Vacancy means hole. Hole means absence of electron, absence of negative means positive. Positive, P for positive, it will be P type. If it was acceptor impurity, this is donor, so negative. Valence of an impurity added to germanium crystal to convert it into P type. If you want to make it P type, P means whole, positive. So there should be an acceptor type of impurity. Acceptor means there must be a vacancy. Vacancy means one less valency than your germanium. Germanium has a valency of 4. So a valency less than 4, which is 3. So option D will be the correct answer. If it was N type, the valency should be more than 4. It will be donor. Donor means 5. That fifth electron will act like the donor. Yeah, very good. Oh, are we going to be 8K soon? Let us see. How soon are you going to turn us into 8K subscribers? Guys, we just need 50 students. 50 students. Are you telling me we don't have 50 students in entire of Karnataka who can make us 8K? I feel by tomorrow this 8K should become 9K. Day after tomorrow it should become 10K. Before physics exam, you don't make it 10K, then you had it. Come on, where are those 50 students? I want them right now, guys. Make this right now into 8K. I want to see, I will come back in a bit. Yes. Come on, I want everybody to smash that subscribe button. Okay? Make your friends subscribe. Even from your parents' phone, from your friend's phone, your maid servant is there, watchman is there. Take their phone 1 second, search YouTube Vedantu Karnataka channel, subscribe. Done. Okay, then next question. The voltage for silicon diode is approximately cut-in voltage. Silicon. Come on, guys. Okay. Come on, 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 guys. For silicon, S for silicon, S for 7, S for silicon, S for 7, 0.7. That is how I remember it. Okay. Germanium means 0.3. Germanium means 0.3. Got it. Ooh, 50 conjues spotted in Karnataka. Very good one, Gopika ma'am. It's time to break. What? Time to break what? Head, bones, laptop? Tell me, what should I break? Forbidden energy band gap in conductors, semiconductors, insulators. EG1, I showed the answer. EG1, EG2 and EG3. See, if you talk about conductors, the band gap is very less. In fact, sometimes it is 0. So it is very less in conductors. Semiconductors slightly more. Insulators very big. That's why the electrons will have to jump with an external source of energy from the valence band to the conduction band. So there is a big energy gap. So for insulators, semiconductors, it is negligible, 1 point something electron volt, and here it is overlapping. So the band gap energy is very, very less. Next, if you take a semiconductor, the concentration is this much and that of holes is this much. The semiconductor is, I mean, look at it. Holes is 10 to the power 12. Electrons is 10 to the power 14. So electrons are more than holes. If electrons are more than holes, come on. Who is it? Hey, who is that, Ray, fellow? Hindi Madi, it seems. Yo. So many Hindi channels are there. And nobody is working for our students here. We were the first ones to launch English channels. And now we are doing it for Karnataka audience. And now we are saying, sir, Hindi Madi. Oh, yo. What, man? Huh. Intrinsic or PNP? Yo, what is this PNP? Nonsense. N type, no. Electrons are more. Electrons, negative, negative. N for negative. P for positive, that is whole. Very good. Okay. Yes. Very nice. Moving on. Which of the following energy band diagrams show N type of semiconductor? N type. Come on, guys. Think. Think, think, think. Hey, waste fellow, stop asking Instagram IDs and all. Concentrate. N type. What will happen? You will add one impurity, which will add one extra what? Donor electron. Donor electron. Yeah, that will make the jump easier. Yes. So that is option B. You can see impurity. There is one extra energy level. So jumping becomes very easy. This is not making it easy so much. This is close to the. Oh, first of all, how can conduction band be below? Conduction band has to be higher than valence band. So diagram only is wrong. Conduction band has to be always higher. Diagram is only wrong. So you will add the donor impurity in between. So the donor impurity can jump easily. The band gap will be reduced. Otherwise, it had to jump from this to this. Now it has to jump from this to this. It is easier. Half wave rectifier. Half means half of the wave. Half of the wave will need one diode. In one AC, positive and negative, each half requires one diode to be rectified. If you take a full wave rectifier, full wave, positive, negative half will require two diodes. Whereas half wave, one diode, only the positive cycle will be rectified. So one diode will be needed. Yes, which one is this diagram? Option A. Guys, capacitor will not come first, diode comes first. So these three diagrams, one diode is there, but don't get confused. The diode should come first, capacitor comes later. Why is the capacitor there? Capacitor is there because of the ripple factor. Yes, there are ripples in the output of the rectified voltage. To reduce those fluctuations, fluctuations, you have a capacitor which can store and give back the energy. So the fluctuations get minimized and you get a nearly constant voltage which is of DC in nature. Okay. Light by mercury vapor lamp is due to. Chandu, I am from India. Next. Come on, guys. Light. Why do you think? Interaction between individual atoms, average spacing between the atoms is large. Okay. Come on. When you have a mercury vapor lamp, yes, mercury vapor, mercury is vaporized. The interaction between the atoms and the atoms will keep on colliding. There is a good amount of spacing between them. So they will keep on colliding. The heat which is developed, they will definitely uh, use that thermal energy to collide. And that's how you will see the atoms interacting with each other will emit radiation during the collision. And that's how you get mercury vapor lamp. So yes, that is correct explanation, option A. If intensity of a destructive interference, what will it be if there are two waves, same intensity, and they are producing that pattern? This is very laddu question, guys. You know it or you don't know it. Yeah. Okay. Okay. Come on, guys. Come on, guys. Tell me the answer correctly. What would be the intensity at some point if it is destructively interfering? Destructive means the waves get destroyed. Nothing is remaining, completely dark. So no intensity. So zero. Yes. C for whom? Captain Shreyas. C for Captain Shreyas. Correct. Very good. Excellent. Moving on to the next question. Ready for it? Oh, yes. Tulin, definitely. We'll give you the PDF. Macha, don't worry. 300 likes. Thank you. Thank you, Bhuvan. Now I want that subscribers also to turn 8,000. In a single slit diffraction, the width of the slit is made double the width. The central maxima will become what? If you make the central maxima, how is it related to the width of the slit? Central maxima will still be there only. It's just that because the slit is wider, more light will pass. If more light will pass, the central maxima will become brighter. So the slit width has become bigger. So more light, brighter. And what will happen? Yes, it will be also narrower. Why is it narrower? It's because what happens is when you make the slit width bigger, then the diffraction will be less. So if the spreading of light is less, so light will spread less now. So you will see the fringe pattern will become shrinked. It will be at a smaller place. If the slit width is small, in a narrow space, the light spreads more. If the space is not narrow, the spreading of light will reduce. So the entire pattern will shrink and the fringes will become smaller. So it is inversely proportional. That's why it will become narrower if you make the slit bigger. Okay. The wavelength, infra, micro, ultra, gamma, straightforward. Wavelength. Topper package, when already made. Topper package video is already made. I don't know how many of you saw it. It's already there, guys. It's there on the channel. Just go to the live part. Yeah, it's there over here. Where is it? See, Namrata man took so many lectures for maths. Now it's the time for physics. So toppers package is there right over here. So watch it, okay? And today I have also uploaded, as shown, all physics derivations. Please watch all the derivations. Sir, what is your plan? I will show you. By the way, 70 out of 70 physics strategy, please check it out. That is a must watch video. Don't delay that particular video. Already it is picking up. Next important thing, my entire plan, what I'm going to do from yesterday to tomorrow. Yeah, it's there right over here. Good news. 7th March, 70 marks target. Complete day-wise plan has been mentioned. Okay, you can check it out. And the day-wise plan has also been posted over here. Yeah, see, it's been posted over here. Whatever I'm going to do in the community. And today is the last day, guys, of Vidya Utsav offers. So please make the best use of all the courses that we have. All those courses I have already mentioned in the previous video. It's also there in the description box of today's video as well. So please make the best use of it, or else you will miss out. The JEE crash course all-in-one test series includes KCT, Comet K, just Comet K, everything. For example, all-in-one engineering test series. Your KCT is there, VIT triple is there, ISER test is there, SRM is there, WBJE, BitSat, Comet K, JEE Mains, JEE Advanced, everything is on offer for 1,667 rupees. I mean, even if you buy one JEE test series, it will be 2-3,000 rupees. Here I'm giving you so many engineering entrance exam test series at an affordable price. Make the best use of it. And some of you wanted, sir, the crash course. That link is also there. And let me tell you, you already have the KCT batch, I mean the KCT test series and Comet K test series combo along with the theory live classes combined in the Crash Pro for 1,999. Some of you wanted the lectures, assignments, sir, class discussions, PYQs, as well as KCT, VIT Triple E, Comet K test series. So this is the batch that you should be looking for. Cool? So make the best use of it. Moving on to the next question coming up on your screen. Here it is. Okay. What happened? Yeah, the correct answer is gamma, ultraviolet, infrared, micro. Gamma is highest energy, highest frequency, smallest wavelength. Ultra, slightly less frequency, so more wavelength. Infrared, even less frequency, so even higher wavelength. Microwave is big wavelength. I mean, comparatively, it's in some millimeters and microwaves, or micrometers. Okay. Velocity of EM waves depends on electric and magnetic properties. Velocity of EM waves depends is in free space is constant. What do you think, guys? Come on, my dear students. What is the correct answer? What is the correct answer? Yep. The correct answer for this, EM waves in free space, velocity is constant. It depends on the electric and magnetic properties. Yes, it is root of epsilon naught mu naught 1 by. So definitely electric and magnetic properties decided, and it is also the correct explanation. Yep, because actually, why is it saying not correct explanation? It should have been option A. In free space, it is constant. Well, that is not the correct explanation. Actually, one is the correct explanation of two, not two is the explanation of one. So yeah, option two is correct. So two is not explaining one, rather one should explain two. Yeah, it is not A, guys. Yeah, be little careful. There is a small play of words. See, statement 1 explains statement 2. Statement 2 does not explain statement 1. Be careful. Ayo, what happened? One second, guys. Hmm. Yeah. Is that okay? Did you understand it? Yeah. Did you understand it? See, the formula is there. Speed of light. What is the formula? Speed of light. What is the formula? 1 by root mu epsilon. So that is why first statement is correct. And why is the second statement correct? Because this will be mu naught, this will be epsilon naught in free space. And that is why this C will be constant. So 1 explains 2. But this is saying 2 is not the correct explanation of statement 1. Correct. Always something should follow something. I am explaining this, that is not explaining me. Understood the difference? That is why B option is correct. Clear? Understood? Clear? Yes, sir. Understand agutte. Power factor is maximum when? Guys, straightforward. Power factor, cos phi. This is a question on resonance. This is just a question on resonance. Everybody should be able to get it. During resonance, power factor is 1 because phase difference is 0 because the inductive and capacitive components cancel out each other. So, XL inductive, XC capacitive cancel out. They are equal but opposite. Hence, option A. Option A. Very good. Study of success. See, my dear, over there. Tell me, electromagnetic waves travel at a constant speed. Why? Because vacuum has permeability of mu naught, permittivity of epsilon naught. So their electric and magnetic properties are fixed. Correct? Permittivity is 8.85 10 to the power minus 12. Permeability is 4 pi 10 to the power minus 7. That's fixed. That is why the speed of light is constant. And the speed of light depends on what? Electromagnetic properties. So speed of light depends on electromagnetic properties, not the other way around. Electromagnetic properties do not depend on the speed of light. So understand it. So from this we can explain, and this says 1 and 2 are correct and 2 is the explanation for statement 1. No, 2 is not the explanation for statement. Next, principle behind working of a transformer is, yeah, transformer, you have primary, secondary. Primary coils produce the magnetic field. That field will go to the secondary. So that induces EMF by Faraday's and Lenz's law. Induction induces. Self-induction or mutual? Mutual. Why mutual? Why not self? Because there are two coils. Coil 1 is primary, coil 2 is secondary. Mutual induction. Self is in that same coil itself. Very good. Study of success is great. You understood. Awesome. That principle of working of a transformer is also very, very crucial. In the figure, the rod is moving towards the left of that loop. The whole setup is placed in a field pointing into the plane of the paper as shown. So, what is the direction of the current? What is basically the direction of the current in that particular left part or right part? Come on, guys. Straightforward over here. As you can see here, as this goes here, this part, you can see the flux is reducing. Why? Because smaller area. Why? Because the area is becoming less in this particular part. If flux is reducing, as per Lenz's law, what should happen? As per Lenz's law, what should happen? You should strengthen that flux because it is falling weak. You have to strengthen it. That means inside you should give magnetic field. Take your right hand, point the thumb in the direction of the magnetic field, point the thumb in the direction of the magnetic field. The fingers show you the direction of the current. So the fingers show you the direction of the current. So the current is clockwise in the left part. current in the left part is clockwise. I think this is what it is. So obviously in the right part, it will be exactly opposite. It will be anti-clockwise. So even if you try doing this part of the question, here the area will increase. So it should be anti-clockwise. Is that okay? You have to use Lenz's law. Yes, B option is correct. B option is correct. Awesome, awesome, awesome. Okay, great, 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 great. We have a very good teacher team plus admin team who takes care of the chats. Don't worry. Ha. Match the following: self-induced EMF, EMF on a rod moving, which is motional EMF, AC generation, transformer. Very theoretical question, theory-based question, my dear students. Tell me quickly, what will self-induced EMF be? Uh, you have to induce the EMF within itself. How can it be mutual? EMF by changing the orientation? No. Motional? No. This is back EMF. So I think self-induced within itself, it is back EMF. When you move the rod, it is motional EMF. Moving motion. Yeah, motional EMF. AC generator, you are rotating a coil. So by changing the loop, so the loop is like this, like this, like this, you're rotating. Orientation is changing. Transformer is always mutual induction. So I think it is A option. Yeah, it is A option. Very good. How many of you said A? Very good. Sound of strings. Sadanand, Kushi, Cynthia. Awesome. Awesome. Great, great, great. Moving on to the next one. The diagram shows a wire carrying current, okay, along the axis of a coil, then, or a ring, basically. When viewed from above, what do you think will happen? Okay. The induced current in the ring is clockwise. If the current through the wire is increasing, current is increasing. Okay. Which direction? Okay. Very interesting question. First of all, because of this current, you know what will happen? Because of this current, there will be magnetic field around it like this. That magnetic field, right, is not causing any flux. The flux is zero through the ring. So if the flux is zero, what will happen? d phi by dt will also be zero. So induced EMF will also be zero. So there is no change in flux. Even if the current increases, decreases, the magnetic field is parallel to the loop. It is not piercing through the loop. So there is no question only of EMF by Faraday's law. So there is no current, no EMF, even when the current is changing. Very tricky question, HOTS. HOTS means higher order thinking questions. Yes, correct. Got it? Super duper question. Awesome. Very nice. Which magnetic property is a strong effect? Para, dia, ferro, both para and ferro. I just told you, dia means go man, go die, repel. It is very weak. Para is okay. Ferro Rocher, very good quality chocolate. Ferro is the strongest magnetic property. So ferromagnetic property is used for making permanent magnets, bar magnets, the magnets used for industrial as well as home applications. Is that right, everyone? Very good, excellent. This question just came, I don't know, just repeated by mistake. Oh, that was the last question, guys. So we have done the MCQs, the 1 marker questions now. So next session, fixed questions, numerical questions, derivations already done, your Xerox paper, your 2-3 marker questions, numerical questions, everything is coming. HOTS questions, everything is lined up. It's already there on the channel. It's up to you now to start working towards it. Okay, all the best. Have a great time. Bega like ಮಾಡಿ, subscribe ಮಾಡಿ, make the subscribers hit 8K very fast. Obviously, if you are watching it recorded, it should be done by now. Make it go to 9K, 10K now. All right, now we are with you. You should be with us. If you don't support us, we will think 2 times now whether we should work for KCT or not. So quickly subscribe, and PDF, yes, we'll be getting it soon by tomorrow. Okay, bye bye. Take care. Have a great time. This was your Captain Shreyas.